So hello everyone, this is EE-542 lab assignment 6, and for this lab we have to implement Hadoop and Spark on the AWS cloud environment. So for part 1 it is Hadoop, and we firstly configured the environment. You can see we created 3 data nodes and 1 name node, which is a master node, and we configured the keys for the master node to log into the data node to utilize them, and these are the configurations. And you can see from here, you can SSH from our master node to the data node, and you can see. As I have started the HDFS function, and we can just see the report. And to test the HDFS, we can use this function, which is to estimate the true value of the pi. So that's it. It's completed successfully.
So right now we already create a Python to write a map and reduce functions. Let me show how to get an output. This is reduce. He's going processing right now. Oh, I see. This is like info streaming. And we type Hadoop FS, get output. And get a user output. Here's like all the texts.
Okay, so here's the Spark session. The first step is running Spark in a single node, and we implement it by using Docker. So here's a command. The environment I use is Docker on Windows, and we can see the container that is running. To establish this container, we can use this command to build a new container using the image here, and then we can access to this container from localhost. So here we can successfully log into the notebook. And now we need to do some analysis on the data set, and the required data set is a data set that is related to body's activity, and the features is the linear acceleration and angular velocity using these sensors. And here is the logic for our code. So first we need to use Spark sessions to create one or get one, and we use the file path to get the file and read it to these 4 data frame. And the next step is these two function which is for data data process. We just split the features into different columns and label the y value, and then we use random forest class model to build the model, and we use F1 score and the evaluator to evaluate the accuracy and F1 score. So here's the details. We use this command to create Spark session, and then we read and cast to float and create a data frame. And then we use the random forest to have this result. And then we need to run in multiple nodes. So we use EMR for establishment. So here we need to log into EMR Studio, and the steps for it. The first step is we need to log in, use IAM user and not the root user, and we need to create a studio custom, give a name, and then we need to use as S3 bucket. We can create one or use a existing one, and we need to choose a service role for it. There are some configuration for this. Role. We need to give EC2 full access and elastic map reduce full access and S3 full access. These mainly 3 roles for this cluster. So here, after we create the studio, the workplace is automatically be created, and then we can log into this workspace. However, to run the code, we need also build a cluster for it. So here we need to configure the cluster. The software is mainly Hadoop and Jupyter Enterprise Gateway and Spark. And here is the instance type for it. We can choose M5 X large for it. And then here we need to configure the core and task. For example, we have 1 core and 2 tasks. And we need to configure the network, and this network is the same to the workplace that we define. So we use the same network for it, and we need to add the SSH key pair for it. And then also we need to use this service role and this instant profile service role for instant profile, and then we can create the cluster. And after it, we need to attach the cluster to this workplace, and then we can have the application loading and running. So here we can see the cluster I use is 1 master node, 1 core node, and 2 client node, which is 2 task node, and we create a S3 bucket for input files and code. And here we run the test, and we can have this result. And then we have the comparison between Spark and Hadoop, and we can see Hadoop is mainly using MapReduce for tons of data, and the result and the input and result is loaded to disk. And for Spark, and they are mainly use memory to store data. So Spark is more faster is faster than MapReduce, and that's the main difference, I think. And here and the last step is the constant program, and we use the program word count, and the code is here, which is very simple. We just read the file and select the value we use and have it group. So here is the core code for it, and we run on EMR and using different number of task node, and the result is things like this. We can see that when we add more task node, the execution time for this word count is declining. So we can see the scalability performance can be improved as we added more machine. So here is Spark session.